Today on How It's Made. Electric vehicle charging stations. Grappa. And lunar rover replicas. Cars powered by electricity were being developed as early as the 1820s. In recent years, legislative initiatives, improved batteries, and accessible methods of recharging have made electric vehicles more popular. Charging stations provide electricity to customers with electric vehicles. It's simply a matter of swiping an access card across the reader, verifying the customer's account, and then plugging the charging station connector into the vehicle. The charging station provides electricity to the charger in the vehicle. It can take 1 to 6 hours before it's fully recharged. The blinking light stops, charging is underway. A laser cutter automatically slices through oxidized aluminum sheets. In a matter of minutes, the pre-programmed cuts are complete. A worker carefully removes the cut pieces of aluminum. Unused pieces will be recycled. Another worker bends the aluminum on a bending post. He places the aluminum piece in a bending machine. Then he positions the bent piece in a pre-programmed robotic welding machine. It automatically and quickly welds the pieces of aluminum together. The worker polishes the welded joints using a soft cloth to make certain they're smooth to the touch. Polishing away rough edges makes the finished faceplate safe for use by customers. A worker assembles the painted faceplate and the head of the charging station. He screws the faceplate to the head and attaches the user interface protection, which is made of tempered glass. He places a flexible strip of light-emitting diodes around the perimeter of the light diffuser. Different colored lights tell the customer whether the station is available and whether vehicle charging is underway. He then places the protector cap containing the light strip and the antenna on the head of the charging station. Next, he connects the various components housed in the head of the charging station. These include circuit boards, the antenna connection, digital display, and card reader. He inserts the control circuit board, which has the central processing unit, the antenna interface, digital display, and card reader on the other side. He uses a flat cable to connect the 40 small connectors of the control printed circuit board to the power printed circuit board. He inserts it into the head of the charging station on top of the control printed circuit board. He finishes attaching the quick connectors. A worker seals the edges of the charging station head with rubber stripping to protect the components inside from the elements outside. He positions the aluminum backplate on the charging station head, and once that's in place, he attaches the charging cable assembly to the connector module. The worker slips the charging cable wires into the frame of the connector module and securely tightens them. Then he positions the connector module door against the frame that holds it in place. He attaches them securely to each other. Using Quick Connect connectors, he attaches part of the plug that links the charging station to the vehicle. To make sure everything is working properly, the worker tests the door sensor and the door locking system. His test confirms the sensor is functioning and the door locks correctly. He now attaches the connector module to the head of the charging station. Then he places the head of the charging station onto its pedestal base. Whether it's being removed or attached to a vehicle, one safety feature is that the connector is never energized when being handled by a customer. Once the charge is complete, the vehicle is ready to roll. Grappa is an Italian brandy, traditionally an after-dinner drink. It's made from pomace, what's left of grapes after they've been pressed to make wine. Distilleries ferment the pomace to convert the sugars into alcohol, then distill it to transform the alcohol and other compounds into grappa. Traditional grappa is colorless. It can also be aged in wooden barrels to produce different varieties with a specific color, taste, and aroma. You can't make grappa without someone first making wine, because wine-making leftovers are the sole ingredient. In Italy, the wine harvest begins in late summer or early fall, depending on the weather and region of the country. The harvested grapes go directly from the vineyard to the winery. There, the first machine pulls them off the stalks, which are later composted into fertilizer for farms and nurseries. The de-stalked grapes enter a cylindrical press. They're crushed against the walls with an airbag-like device to extract the juice and pulp for making wine. What's left behind in the press, once the juice and pulp drain out, are the skins, seeds, some residual juice, and pulp. This is called pomace. The winery sells it to distilleries that produce grappa. This small artisanal distillery produces premium quality grappa by using only pomace from grapes pressed that very same day. The pomace goes into temperature-controlled fermentation tanks as soon as it arrives. Large industrial distilleries operate differently, typically warehousing pomace prior to processing, sometimes for months. This delay produces high levels of potentially toxic methanol, which the distillery then has to remove using an additional procedure. The distillers monitor pH and alcohol levels to determine when the conversion of sugars to alcohol is complete. The process takes from 3 days to a week, depending on the variety of grape and other factors, such as the outdoor temperature. When the pomace is ready, they transfer it to wood-clad copper stills. They heat the stills with steam, bringing the pomace to the boiling point, which transforms the alcohol and other compounds into steam. This alcohol steam inside the still rises to the top and exits through a side hole. It travels through copper pipes and other equipment, ultimately to a condensation system which cools the steam back to liquid. This liquid is grappa. As it exits distillation, the master distiller meticulously monitors the temperature and alcohol level. She discards the initial and final flows, capturing only the perfectly pure mid-flow, referred to as the heart of the grappa. Its alcohol level at this point is 70 to 77%. Certain varieties now go to the cellar, into small wooden barrels to age. Over time, both the grappa and the wooden barrels exchange compounds, which influence taste, aroma, and color. For example, a barrel made of cherry wood will produce different characteristics than one made of oak. The distillery's experts analyze and taste samples following distillation and throughout the aging period. Depending on the variety, this can range from just 1 year to more than 20 years. Whether the grappa is aged or not, prior to bottling, they filter and dilute it with demineralized water. This lowers the alcohol content from an average of 77% after distillation to the target level of 41 to 50%. They seal the bottles with stoppers made of food-safe synthetic materials rather than traditional corks. Natural cork contains certain organic compounds which can alter the flavor, aroma, and color of the grappa. They seal the stopper with shrink-wrap plastic. An unbroken seal assures the buyer that the bottle has not been previously opened. Then the bottles pass through a labeling station. The grappa is ready to be poured as an after-dinner drink or enjoyed on its own. As the Italians say, salute. On July 26, 1971, the Apollo 15 space module touched down on the Moon, and astronauts emerged with a new vehicle, the Lunar Rover. They took it for a test drive. It handled well on the rough surface of the Moon, so they could venture further from the landing site and really explore. The Lunar Rover was no ordinary four-wheeler. Millions of dollars of research went into this one-horsepower wonder, which became known as the Moon Buggy. Today, craftsmen build replicas for space museums and to use as movie props. The team starts with a substantial suspension system designed to smooth the ride over the Moon's rocky terrain. They then install a steering plate at the front. They attach actuators, which are mechanisms that assist in steering. They connect the actuator drive bars to the steering plate. Together, the steering plate and actuators give the Lunar Rover an incredibly tight turning radius of 10 feet. They screw support brackets for the actuators to the corners of the chassis. They then connect the actuators to them. They use steel and aluminum bolts and parts. However, on the original Moon Buggy, many parts were made of titanium because it lightened the load carried into space. Titanium is expensive and unnecessary for this replica. The fenders are next. They are extra large to protect astronauts from lunar dust kicked up by the rover. They insert a locking mechanism in a slit at the end of the drive shaft and slide the wheel hub onto the shaft. They turn the hub to lock it in place. They're now ready for the wheels. In the atmospheric vacuum of the Moon, air-filled rubber tires were out of the question, so the original rover had wire mesh tires. To mimic the look, they've wrapped a wire lattice around rubber tires. The team secures the wheel to the hub with a plastic and aluminum cap that's equipped with locking pins. They give it a spin and install the other three wheels. Next, a technician assembles the instrument panel. He inserts various switches and gauges into their slots, including this system reset switch. It's used to bring the displays back to zero prior to an expedition. He closes a two-piece collar around the bottom of the switch. He locks it in place with the top cap. He then flips the panel around and tightens the nut on the back part of the switch. With the system reset switch now attached, the instrument panel is complete. He places it in the housing. He installs metal bars around the switches to keep them from being accidentally tripped. He assembles the steering handle, which is a T-shaped joystick, next to the instrument panel. They now transfer the steering and instrument panel assembly to the vehicle. They fasten the actuator switches to the steering housing. And and then clip the wiring harness to the floor of the lunar rover. They cover the bottom of the rover with flame-resistant material. They lower the electrical control panel and battery into the chassis and connect them. The original rover had 2 small batteries, but the mechanics of this replica have had an update. Stay tuned for more as this lunar rover replication mission continues. The original lunar rover weighed just 460 pounds, or 77 pounds in moon weight. It could carry a load of over twice that. In minimal gravity and an atmospheric vacuum, it was the only way to travel on the surface of the moon in 1971. The production of this lunar rover replica continues with the fabrication of a brake disc. The technician carefully measures the dimensions and draws them onto a sheet of plastic-covered aluminum. He drills a large hole for the main drive shaft and 4 screw holes. He then cuts out the disc following the penciled lines. He smooths the rough edges using a fine grit abrasive belt. He sands off the plastic liner and abrades the aluminum surface to a satiny sheen. The brake disc is now ready for assembly to the lunar rover. He attaches it to the main drive shaft and lowers the assembly into the vehicle. He bolts the disc to the chassis, where it will serve as a friction surface for the brake pads. He installs those next. He connects it to a spring mechanism for engaging the disc brake. He tests the drive shaft and disc brake and confirms that they're both in working order. He loops a roller chain around the sprocket gear for the rear-wheel drive and the teeth intermesh. He drives pins through the links to join the ends, closing the loop. This drive chain is powered by an electric motor. It's another mechanical modification. On the original rover, there was a small motor for every wheel and no drive chain. The lawn chair-like seats are next. They cover the shocks and battery at the front with an aluminum hood. They also install a cover over the mechanics at the back. It doubles as a rack for geological excavation tools. They attach the umbrella antenna to the rover. It was used to beam pictures and data to Earth. Next, an aluminum cylinder spins in a lathe as cutting tools transform it into a camera mount. They also create a bracket for a communications antenna. It's quite a transformation. Using the bracket, a member of the crew now erects the communications antenna. He then installs the mount for the film camera. Next, using a shear press, he lops off a piece of an aluminum sheet. He switches to a hand tool and cuts out a geometric shape with flaps. He folds up the flaps using a brake press, creating a box to cover the main battery. After the seams have been welded, he wraps the cover in Mylar, which is a strong plastic film. The wrap is an extra layer of protection against windborne particles, known as micrometeoroids. They also wrap the camera and other parts of the rover with Mylar. This replica of the Apollo lunar rover is complete and ready for display. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.